All right, I'm going to kick things off here. Thank you everyone for joining. We proudly present the next installment of Edrans TechTalks. Today we'll be discussing the Well Architected Framework and how companies are leveraging serverless technology to modernize their applications. Talk will be about 30 to 45 minutes, and you can ask questions in the chat function in your GoToWebinar control panel, and we will do our best to get to all the questions as time permits. So, my name is Joe Henderson. I'm the General Manager of Edrans North America, and today I'm joined by Chase Douglas, the CTO of Stackery.
Hello.
Hey, Chase. And today's agenda, we're going to do a quick overview of Edrans. We're going to discuss the Well Architected Framework and why companies are interested in serverless technology and why we often recommend that to our customers. Then I'll kick it over to Chase, and he'll dive into what serverless is and how Stackery is helping customers design, develop, and manage the ongoing delivery of high-performing and cost-optimized applications. So here we go. So just as a refresher for some, give a quick overview of Edrans here. We are a premier AWS consultancy, and we've been doing cloud services for the past 10 years. We have offices in Portland, Oregon, Buenos Aires, Argentina, and Barcelona, Spain. We serve customers all over the world. We deliver services like cloud migrations, managed services, and well-architected reviews, as well as software development. So just as an overview for some, the well-architected framework are the best practices and design principles of 5 pillars of the cloud infrastructure: operational excellence, security, reliability, performance efficiency, and cost optimization. So over the past couple of years, we became a part of the AWS Well Architected program, and we've given these well-architected reviews or assessments or kind of workshops to many customers all over the world. So in the time we spent with our customers doing these assessments or workshops, the topic of moving to serverless has become more and more common. And it's often a top recommendation that we give our customers when we present them with a plan on how to become more efficient, high-performing, and cost-optimized. So just quickly, so why are some customers asking about serverless, and why are we recommending it? Number one, definitely speed. So by adopting serverless technology, developers don't have to worry about managing the underlying infrastructure that supports their code, and they can move faster in a more focused way. Next one's definitely cost. So with serverless, teams don't have to worry about managing and monitoring servers in dev, test, and production environments and paying for idle instances. So we're not talking about saving 5, 10, 15%. We're talking about sometimes up to 70, 80, even 90% in cost savings. And sort of the sum of the first 2 points here, it's all about scale. So building serverless architecture kind of eliminates that infrastructure constraint and allows teams to grow without massive investments in time and cost. So now I'm going to kick it over to Chase, and he's going to do a deep dive into really what is serverless and how Stackery is helping companies securely modernize their applications. Over to you, Chase.
Thanks, Joe. As Joe mentioned, I'm the CTO and co-founder at Stackery, and our goal is to make companies successful as they're adopting modern best practices on AWS. So we started out creating the best platform to securely design, develop, and deliver serverless applications on top of AWS. What I'd like to do today is focus a little bit on what is serverless, what does it mean for companies, how is it that it actually helps them achieve benefits like faster time to market, 90% cost reduction, higher scalability horizontally, and then start to take a look at what that means in the context of trying to modernize an application. So the key with serverless is realizing that businesses today, they're all application driven, but to build those applications, you have to have some kind of underlying infrastructure. And unfortunately, most organizations and teams get lost on the plumbing infrastructure needed to deliver their application and aren't able to focus enough on delivering the value, the business specific differentiating logic that really drives the benefits for their customers. This here, by the way, is a map by someone named Simon Wardley. He does a great job of kind of mapping out using this value-based mapping system to help companies identify how they should adopt best practices. And through this process, I highly recommend taking a look if you want to dive deeper into this. He's able to, really articulate a lot of business case statements for how serverless is beneficial. But we're going to go a little bit higher level. We're going to define first, what is serverless? And what does it mean in your application architecture? I like what Cloudflare has as a definition. Serverless computing is a method of providing backend services on an as-used basis. A serverless architecture allows users to write and deploy code without the hassle of worrying about the underlying infrastructure. So it's all about building your application with the business logic that differentiates you without having to worry about how the underlying infrastructure is operated. What that means when we think of how an application might be constructed is where in the past we might have had a monolith, or at best a two-tier system where you've got a web server that serves the front-end content and it talks to a database to store data, and that was it. Now applications in the cloud environment are built as a combination of different services. In the past, we'd call this a microservice approach, but that would oftentimes mean you would have to build each of these individual pieces yourself. In the serverless case, what it means is you are taking these microservices as pre-built building blocks that your cloud provider, that AWS gives to you to use. So instead of you having to figure out how to take a bunch of servers in a rack, AWS has done the hard part of turning those into services that are API gateways, that are databases themselves, that are functions as a service, places to store your data like S3, queuing systems like SQS or Kinesis. All of that has been built for you to take and use off the shelf, so that instead of you having to cobble together your own mechanisms for queuing, for PubSub, for database maintenance, instead, you can rely on AWS and all of their expertise, knowing that it is well architected from the ground up to be scalable, to be performant, and to share the load across all of their customers, which can give cost benefits. So when we think of the serverless benefits to you as an organization, it really comes down to the fact that the cloud provider knows how to run their clusters of services 24/7, tune it for performance, and spread that cost across all of the cloud provider's customers, which gives you higher scalability, higher performance, and lower cost. So if we dive into that cost bit a bit more, this diagram starts to show why it is serverless can be really beneficial. So as you've got a new project, it starts at, practically no one's using it, but over time it's going to scale up as you're successful. If you have to provision your own servers in a data center, you're always having to over provision the number of servers because you have to have that capacity as your throughput in your system rises over time. But what that means is there's periods of time as you add more compute capacity that you're just sinking upfront cost. And that is cost that isn't being utilized and is effectively being thrown away at that point in time. But with serverless, you pay only as your compute is used, which allows you to pay very optimally against your infrastructure usage. Let's take an even closer look at this. So the blue line here is showing how your throughput, the traffic to your web application, may vary over time. Now the timescale isn't labeled. This could be over hours, this could be over days, this could be over months or even years. Let's say that you're a tax service company. You're going to see peaks every April. Now, if you're doing data center-based self-service server provisioning, then you have to be very coarse about how and when you add servers. And you don't really have the ability to decrease your capacity over time. So the distance between the blue line and the red line is lost cost that you're having to pay that you're not utilizing in your data center. As we move to the cloud, we can get better. We can start to manually add new virtual servers and scale them back over time. That gives us an ability to closer track and shrink down the amount of cost that we are inefficiently paying for. Auto scaling gets us even closer, where we have algorithms that watch for usage trends and can scale up and scale down servers. But the full realization of what the cloud can provide to you is with serverless, where you aren't actually scaling anything. You're asking the cloud provider to scale it for you, and the cloud provider in turn charges you only for the compute utilization that you actually consume. This gives a massive amount of cost benefit when you've got highly variable traffic, when you've got spiky traffic. It also gives you cost benefits when you are building out a development team, because it's one thing to have to follow your production traffic and match cost to it, but oftentimes you might have a development team of 10 engineers. And if every one of those engineers has to spin up 20 microservices to be effective, to be able to develop and iterate on the software, it's going to be extremely expensive because they're going to have extremely underutilized service instances, because during development, you might hit something with 5 requests over 10 minutes and then not even hit it for the next day or two until you come back to that project. Joe Henderson at Branch Insurance, one of our customers at Stackery, he's talked about recently what his AWS bill looks like. He's got a new insurance startup that is selling into 5 states, and their April AWS bill was just under $740. In comparison, when he's built startups in the past and he's gotten to this stage where he's had to have a dozen team members on his engineering team be able to spin up their own instances, he often found that it would cost $15,000 a month to run. This is very typical, even at small scales of early startups, let alone larger scales of medium-sized businesses or enterprises that have to pay lots of money for servers and potentially even licenses on top of that for different types of products that give you clustering and service capabilities. But serverless isn't just for greenfield applications like Joe Henderson built with his new startup. MasterStream is another one of our customers. They took an existing service they had that wasn't scaling the way that they needed it to in their data center. They hit limits on their capacity and they couldn't scale fast enough. So they moved to the cloud. The problem then, though, was they just lifted and shifted their virtual machines into the cloud without refactoring it for the benefits that the cloud can provide. So their cost went up, shifting from the data center to AWS, although they did gain the elasticity of being able to spin up new virtual servers at the click of a button. But then they switched and they used Stackery to refactor their variable throughput and high throughput routes of their applications. And with that change, they dropped their AWS bill by an order of 90%. 80 to 90% is actually a very common cost savings that we see when people modernize their applications from monolithic server-based instances into serverless. There are many case studies. We have them, AWS has them, other serverless companies have them that show this consistently. 80 to 90% reduction in cost when modernizing. There are many reasons for this. There's challenges when you're dealing with traditional monolithic apps that break down to cost with how it scales. So oftentimes when one process, one route of an application experiences a spike in demand, the entire architecture has to be scaled. So you can't scale efficiently across different pieces of your architecture. As your code base grows, you lose the ability to be nimble and develop quickly because you're working with a monolithic application where any individual change could affect the behavior of many different components. And that adds risk. So these are some of the challenges inherent to traditional monolithic apps, on top of the infrastructure costs that we were talking about a minute ago. So why modernize? Again, it goes back to that 90% reduction in cost, but also a large increase in velocity when you have the right tools, like Stackery. Tim Wagner, who's the founder of AWS Lambda and the concept of functions as a service, he took Stackery after he had built his own version of a WebSocket API using AWS API Gateway, Lambda functions, and DynamoDB for a project he had. He built that out himself using the tools that his teams at AWS had built, and it took him 15 hours. And when he used Stackery, it took him 15 minutes to reproduce the same thing. So one of the challenges that people have when they think about modernizing is how much time it might take to refactor and then be able to achieve their velocity increases. And the nice thing is, with the right tools, you can get your cost reduction and you don't have to sacrifice speed because it's quick to re-implement the most business critical parts of your application. So what makes modernizing so hard at a technical level? There's challenges with inconsistent deployments, complexities as applications scale, the rapidly evolving library of AWS tooling, the relationships between services can be hard to understand, and they're different between every pair of services that you need to piece together. And there's this sense of a new foreign software development workflow that you have to conquer as you are shifting from traditional monolithic style applications into serverless applications. But there are patterns that you can follow to be successful. The best way to refactor, to modernize microservices, is to look at refactoring individual API routes, not the entirety of a service, but just those routes that are most impactful to your business. These could be routes that aren't scaling well today. You hit peaks in your traffic load, and when you hit those peaks, you don't scale as well and you start to fall over. Could be that they're error-prone routes. Could be that they're high-cost routes for one of a number of reasons. If you can identify a handful of routes that are impacting your business by either causing you to lose business or causing your costs to increase, then those are the routes you can focus on while leaving the rest of the routes implemented the way they are. And we'll take a look at how to do this in a minute. You also want to leverage cloud-native building blocks as much as possible. So don't go and re-implement SQS queues. Go and use SQS as a queuing service for your own benefit. You'll need to have tools that help you visualize your infrastructure, because as you're moving to this modern microservices as a service based world, You have to be able to see how your system is uh, put together, how the events flow through it, not only as an individual, but imagine you've got a team of developers and they need to onboard new team members who need to quickly ramp up to understand the architecture of a system. It's important for everyone to be able to quickly identify and understand what the relationship is between two different pieces in your infrastructure, and visualization is an important aspect of that. It's also something that Stackery does uniquely by providing this visual editing canvas that lays out your infrastructure as code, CloudFormation or AWS SAM, that describes how your applications are built. And lastly, you need a way to securely manage your environments that you're deploying into, development, production, and test. This is where Stackery comes in. So Stackery helps you design with a visual editing canvas where you can lay out your resources, add new ones, connect them together. It then helps you develop by providing new workflows for faster local development and iterative strategies. And then lastly, it helps you define environments inside of your AWS accounts, giving you access to easily create parameterization for your infrastructure, to create secrets, places where you can put API keys or say database passwords inside of the proper locations in your AWS accounts. So for parameterization, you've got Systems Manager Parameter Store. For secrets, you've got AWS Secrets Manager. Stackery helps you put all of this data in just the right locations for your environments inside of your AWS accounts. And it empowers you to leverage the most common infrastructure resources people consume as they're building modern applications. All kinds of leading organizations, big and small, are using serverless successfully. This is just one small smattering of companies that are name brand doing amazing things with serverless. About half of them on here are Stackery customers as well. Everyone is starting to turn towards serverless because of these benefits, especially now with the cost savings that they can achieve. And that's something I'm really excited about. So with that, I'd like to do a really brief demo where we show what it takes, what it looks like after you've refactored parts of a monolithic .NET application into serverless. So as a quick overview, we have set up a two-tier application. A typical application we've written in the .NET framework runs on Windows servers talking to, I know that this diagram shows MySQL, but in our instance, because this is a .NET framework application, we're talking to a SQL server, a Microsoft SQL Server instance. It's a catalog for books that contains records for books and the authors that wrote them. And the problem I'm trying to solve is that I've identified that my books-based routes don't scale well. And I'd like to use serverless to refactor this application. So we're going to start by taking a look at the application I have today. This is Elastic Beanstalk inside of my AWS account. Elastic Beanstalk is an easy way to spin up something like a monolithic application. And here we've got our .NET framework running on Windows Server. I can open up the link to my application and go to the specific routes that we're going to be interacting with. Here I've got my books routes. It returns everything in traditional XML from the .NET framework. I can pick out a specific book as well. I can also look at my authors route. So these are the two routes that I've got in my application. And I want to go back to my books route and refactor it using functions as a service, Lambda, still talking to the same database, but by using Lambda, I'll get better scalability and better performance for these routes. So how do I refactor just these routes? Well, I've got my project open here in Visual Studio Code, my favorite IDE. This is my .NET Framework web API. And there's a handful of different pieces of the project that are important here. We've got our model for our book records, a model for our author records. These are what data is stored in our database. We've got some code here that connects to our database server. And lastly, we've got this controller that implements all of the routes, like getting all the books, getting a specific book from our database. We have both a books controller and an authors controller. Now, what I'm going to do is I'm going to start to refactor this by using some infrastructure resources. So here is my refactored application, and I want to first start by looking at the CloudFormation or AWS Serverless Application Model, SAM for short, the infrastructure as code template that I built out. Now I'm looking at this in its pure code form, but I can also pull it up in the Stackery Visual Canvas editor that will lay out that infrastructure code so that I can more easily understand how things are put together. In this Canvas editor, I've got the ability to drag and drop new resources as I need. But for now, I've already got this built out, and this is more of a show and tell demo. What I want to draw your attention to is a couple of things. First of all, I have this record here of my existing database. And I've told it, instead of provisioning a new database, it should talk to this existing database that I have in my account. I also have the secrets manager as the location where the database password is stored so that my Lambda function that I have here can access it. As I've wired up this Lambda function, which is going to be my compute resource for servicing the books routes, by wiring them up inside of our canvas, that did two things. It gave us permission, as we wired it up to the secrets resource, to grab the database password from Secrets Manager. It also, as I wired up the database, it gave me information about the location of the database in my environment variables so that in my source code, I can find it once this is deployed. We'll look at the source code in a minute, but now that we've got a function here that has code and can access the database, now it's time to look at how we've constructed our API. So I've constructed the API with 3 routes. There's a route that sends traffic to /API books. When that route is hit, it spawns an event. It invokes this Lambda function to service the request. I've got this route here that services /API/book/star that also sends all of its events to invoke this Lambda function to handle the requests from clients. Lastly, though, and this is the key part, we didn't re-implement the entire API. So we haven't re-implemented API/authors. That's okay because we have a default route that's hooked up to send all those requests to the existing API when it doesn't match any of the routes that we've set elsewhere. So now that I've got this infrastructure scaffolded, I can see that what I've done is I pulled in the exact same models from our .NET Framework API. We didn't have to change anything there. For our database connection, we added a little bit of code to retrieve the database password from Secrets Manager, and then to construct a SQL string to inform the .NET framework how to connect to our database. And lastly, we've made some small changes between the books controller that we have from our .NET framework into the .NET Core version of the Web API, which has some minor changes so that it can run on top of Lambda, which is a Linux environment. .NET Core is where all .NET development is moving. And so this is also a great opportunity to upgrade some of your functionality piece by piece from the older .NET framework into the .NET Core framework. So now that this has been re-implemented, I've deployed this out into my environment managed in Stackery. So this is going to show me the exact same view of my infrastructure as we were editing a minute ago, but this has now been deployed into my AWS account. So now I can open up my API and find the staging location for it. We'll see that it's already proxying most of the routes to my existing API. We'll see here, I get back the author's data that looks the exact same way, has the exact same data and format as our original API. But now, if I take a look at the books route, which we re-implemented with Lambda and .NET Core, the newer modern .NET Core framework returns results by default in JSON form. And so we can see that as opposed to the original implementation from our .NET framework, older monolithic approach, it came back as XML. Now it's coming back as JSON from our Lambda function. So this has been a quick show and tell of what it looks like to refactor little bits and pieces of your .NET application to achieve the cost benefits. Again, 80 to 90% reduction is very typical for applications as they move from monolith to serverless. It then gives you benefits for scalability, reliability, and gives you the ability to break things down and have faster iterative development for newer extensions of your applications. So with that, I'll turn it back over to Joe. I, again, want to thank him for the opportunity to share a bit about how Stackery can help people build serverless applications or modernize serverless applications.
Thank you very much, Chase. Don't have any questions at the moment. We just wanted to say thank you for joining today. If you'd like some more information, we'll be sending out a follow-up to everyone that attended, as well as the video of this. We do offer what we call Well Architected Reviews plus a serverless readiness assessment. So if you'd like to spend some time with Edrans and Chase and the Stackery crew, we're happy to set something up to discuss that. And Stackery is available via the AWS Marketplace. And as a partnership between Edrans and Stackery, we actually have some marketplace bundles where we compare our services with the product as well. So thank you again, everyone, for attending. We really appreciate it, and have a great day.